So tonight we're going to do some revision of the cubic function, just the basic stuff, not the more sort of complicated questions, but don't worry, we will do those throughout the year so that by the time trials and finals come around, you will be completely ready. The first question, 8.4, is not strictly a question about the cubic function, but it's related to the cubic function, and it's something that I would hope we would all be able to do. Okay, so let's just have a look at the question. It says if g of x equals negative 8x plus 20, and this line g of x is a tangent to f of x, which clearly is a cubic function, at x equals 1. So they've given us the x coordinate at the point of tangency. They want us to calculate the values of a and b. So they're basically asking us to determine the equation. Right, so this is something that we practiced a little while ago. Let's see if we are able to put those skills into practice now with the addition of the word tangent. Okay, so first of all, what is a tangent? What's a tangent, Matrix? You can put it in the chat if you don't want to unmute. What is a tangent? Okay, so a few options here. Okay, a line that cuts the circle at 2 points, says Batibile. A line that touches the circle at 1 point, says Rafenswe. Lebogang, a straight line. Bianca, a line that touches a circle once, a line that touches a circle at 1 point, a line touching a circle, a line that touches a circle at 1 point. Okay, so most of you are correct, but it's not just circles, okay? A line that is a tangent is a straight line that touches a curve. Okay, so the curve can be a circle, or it can be a parabola, or it can be a cubic function. All right, so if it's a curved line and a straight line touches it in one place only, then that line is called a tangent. Just going back to one of the first comments that was made, Batabile, this is for you, okay? If a line cuts a circle in 2 places, then it's called a secant. Okay, so that's spelt like this. Okay, that's a line that touches a circle or cuts through in 2 places. All right, so a line that is a tangent will only touch your function in one place. The other thing that I want to ask you before we get started, right, is what is the gradient of g of x? What's the gradient of g of x? There we go, Nhlanhla. It's negative 8. Okay, so we know the gradient at the point of tangency because the gradient of the straight line, if it's touching the function f of x at that point, that must be the function's gradient as well. Okay, so does that make sense to everybody? Okay, so at x equals 1, the gradient of the tangent is negative 8, and therefore the gradient on the cubic function will also be negative 8 at that point. All right, we also know the x coordinate at the point of tangency. So they've given this to us, they've told us that it's 1. So the x coordinate at the point of tangency is equal to 1. What is missing from this information that they've given us is the y coordinate at the point of tangency. We don't know what that is. Do we have a way of being able to calculate it? Can we work out the y coordinate at the point of tangency based on the information in front of us? Can we calculate the y coordinate? Yes, we can. Okay, how, Rafense? How can we calculate the y coordinate at the point of tangency based on the information we've got? What can we do with it? There we go, Mamelo. We're going to sub x equals 1 into g of x. Lovely. Well done. Okay, so we can sub 1 in. So either we can write it as y equals or g of 1 equals. Doesn't make any difference. And that gives us negative 8 times 1 plus 20, which gives us 12. So we know the y coordinate at the point of tangency. All right. The other bit of information that they've given us is the equation of f of x, but a and b are missing. All right. Can anybody tell me what shape is f of x? Use the words concave up and concave down. What is the shape of f of x? What is the shape of f of x matrix based on the information that's given? Okay, so a quadratic function can either be concave up or concave down, but cubic functions are both. All right, we've just got to know what they are first. Is it first concave up and then concave down, or concave down first and then concave up? So Lebogang says concave up, then down. Nhlanhla says concave down and then concave up. So Nhlanhla, you're the only person who's put the correct answer into the chat so far. Okay, that's it, a P-ware. First it is concave down and then it is concave up. Okay. The reason that we know that is because the number in front of the x cubed term is a positive one. All right, so when a graph has the number in front of the x cubed term is positive, then that means that the graph is first concave down and then concave up. Okay. So this particular tangent touches the graph where x is equal to 1 and where y is equal to 12, right? They want us to calculate the values of a and b now. All right, so what can we do with the 1 and the 12? How can I use the 1 and the 12? What am I going to do with them? What can I substitute them into to give me an equation with a's and b's in it? Sub them into f of x. There we go, Gugu, lovely. Yes, Lebogang, that's it, great. Okay, so I would write 12 equals 1 cubed plus a x squared plus bx plus 18. And I could simplify that. So that gives me 12 equals 1 plus a plus b plus 18. And let's leave our a plus b on the right and take everything over to the left. So 12 minus 1 would be 11, and 11 minus 18 would leave us with negative 7. Okay, lovely. So that gives us our first equation in terms of a and b. How are we going to make our second equation matrix? What are we going to do? Derive. Yes, Mamelo. Okay, so Mamelo, I'm going to derive f of x. So I'm going to write that as f prime x. That's going to give me 3x squared plus 2ax plus b after I've derived. Now that I've derived, what am I going to do with my derivative? Shem, it's okay, Lebogang. What am I going to do with my derivative? Sub in an x and a y value. Okay, remember f prime x is not y in Nhlanhla. F prime x is gradient. Okay, so again, you know the gradient at the point of tangency, you know the x-coordinate at the point of tangency. How can you use those? Sub in -8, absolutely. So I'm going to sub in -8 in place of f of x, because that is the gradient at the point of tangency. I can also sub in that x is equal to 1, because I know that when x is 1, the gradient is -8, plus 2a times 1 plus b. So that gives me -8 equals 3 plus 2a plus b. Let's just fix that plus up. So -11 is equal to 2a plus b. There we go. And now we have made our second equation. All right, so before I go ahead and go and solve these, or actually I'm going to let you solve them, I just want to see if there are any questions. Are there any questions on what we've done so far? Does everybody know why I have made the second equation equal to -8 and subbed in 1? Hmm. Yes, Leanne, you can use minus a minus 7 equals b. Or if you make a the subject of the formula, either one of those two, Leanne, are fine. Okay, Gugu, you're welcome to unmute and speak, Gugu. Amahle, I think I'm going to answer your question at the same time. Gugu, you're
Good
welcome to
evening, ma'am.
unmute. Good evening, Gugu. How are you?
I'm good, thanks, and yourself?
I'm fine, thank you. Do you want to ask a question?
Yes, ma'am. Will it be wrong for me to derive f of x first before f of x first, then find the thingy?
No, not at all. So it doesn't matter whether you do the pink step first or the purple step first.
Oh,
Okay,
okay.
either or. Does the order in which you do those two things doesn't matter. It's not important. Okay,
Okay, thank
or
you, ma'am.
all right, no problem. Okay, so you guys go ahead and work out the values of A and B. I'm just going to answer Amahle's question. Okay, so Amahle, all right, we know that the gradient at the point of tangency is -8. Okay, here they told us in the equation of g of x. Okay, so g of x with equation minus 8x plus 20 is a tangent to f of x at x equals 1. All right, so that's them telling us that the gradient at the point of tangency is equal to -8. All right, so that's why when we take our derivative, we have to sub in -8, the gradient at that point. Okay, when x was equal to 1. Okay,
Wait,
so what we are saying in this line over here is that the gradient at x equals 1 is -8. All right, so that's what we're doing in that line over there.
Ma'am, could you say that the gradient is, well, wait, let me try phrase this. So because we know that the equation of a tangent is the derivative of at that specific point on the
Okay,
graph. So can
okay,
we say that that gradient is essentially going to be a y value?
okay. So you mustn't get confused between. I hope this is what I'm answering you. You mustn't get confused between f of x, which is y, and f prime x, which is gradient. Okay, so in this line, this first line of pink writing over here, I'm subbing into f of x.
Okay.
Over here, I'm subbing into f prime x. Okay, so you've got to sub into f of x and you have to sub into f prime x.
Okay.
All right.
All right. Thank you, ma'am.
Okay, no problem. So Nhlanhla's already got answers. Let's just see where the rest of you are. Okay, so I'm getting the same as you in Tlantla. I'm getting A is equal to -4. And then if we go back and work out B, we get -7 equals, sorry, A is -4. Plus B, so B would be equal to -3. Okay, and Tlantla, I agree with you. Let's just see how everybody else is doing. Okay, so Leanne, again, I was talking to Amatle about that earlier. All right, the gradient at x equals 1 is -8. That's what they were telling us here by giving us the gradient of the tangent at that point. Okay, so that's why when you sub into f prime x, you've got to make the gradient equal to -8. Okay, because that's the gradient at that point. Okay, it's not the turning point. Okay, that's where we would make the gradient equal to 0. Okay, Gugu, I see you've got a hand up. You want to unmute and speak, Gugu? No, Gugu's gone. Okay. Oh, you're all right. Aaron? Maybe you're having problems being heard. Okay, so everybody should be fine with that question. Any last questions before I move on?
Sorry, Teacher Lee. Aaron is experiencing some audio problem, but Lebu's hands is up.
Oh, okay. Lebo? What do you want to ask, Lebo?
Good evening, ma'am.
Good evening.
Good evening, ma'am. If, like, in a situation they ask us to find the tangent of a line using parallel or perpendicular lines, how do we do that, ma'am?
Okay, so not a problem. If lines are parallel, then your gradients are equal. If lines are perpendicular, okay, then the product of the gradients is -1. Okay, so if lines are parallel, excuse me, if lines are parallel, then gradients are equal. If lines are perpendicular, then the product of the gradients is -1. So just quickly here on this side, let me just scooch over. Okay, so if they say to you, determine the equation of a line parallel to y equals 3x plus 8, and then they give you the coordinates of the point that it passes through the x and y coordinates, you would then simply take that 3 and you would use that. Okay, so your equation would be y equals 3x plus c, and then you'd have to go and sub in your x and your y in order to work out your c value. If they tell you that you've got a line y equals 3x plus 8, and there's a line that's perpendicular, you'd first have to say, all right, that 3 times the gradient of your perpendicular is equal to -1. So the gradient of your perpendicular, you're going to have to divide by 3 on both sides, would be -1/3. So then your new gradient is -1/3x plus c, and then again, you'd have to sub in your x and your y to work out your c value. Does that answer your question? Okay, so so that's just something that we have to learn. The gradient of parallel lines is equal. The gradient of lines that are perpendicular, their product. When you times the gradients together, you get -1. Okay, so just before we move on, Unati, you said that you were getting 4. Did you use substitution instead of elimination? Because you should be getting -4 and not 4. So Unati, if you have a look over here, I've used elimination. So -11 plus 7 would give us -4. Okay, so Unati, maybe we can come back and just talk about that on the side. I just want to move on to the next question now. You can see it. Okay, yes, and Nhlanhla, take a screenshot of the question. There you go. There's everything on the screen at the moment. I suppose there's just one little thing missing. Okay, so screenshots, everybody. There we go. Okay. All right. So let's go on and have a look at question 9. Okay. So here they've given us f of x. It equals x plus 2 times x squared minus 6x plus 9. And they've said that equals x cubed minus 4x squared minus 3x plus 18. So they've multiplied out the brackets for us. So they've given it to us in factorized form, and they've given it to us without the factors. The first thing that they are asking us to do is calculate the coordinates of the turning points of f. Okay, so when we want to calculate the coordinates at the turning point, what do we need to do, Matrix? How do we calculate the coordinates at the turning point? What do we need? For the turning points. Okay, I see this. Okay. Lebogang?
Ma'am, do you need to find the derivative first and then solve for x?
You do. Okay, so you've got to find the derivative. Make sure that you show that it's equal to 0 because the gradient at the turning points is equal to 0. And then go ahead and solve for x. Okay, so you guys do that. And we'll see afterwards if we get the same answers. So go ahead and work out the coordinates at the turning point. Please, can we just mute? Thank you. Yes, Aaron?
Aaron is still experiencing audio problem. I think I'm gonna talk to him privately, which I did, but he must just respond, but he can't hear me. That's
Oh,
my
shame. Oh,
yeah.
so you're having to type to him.
Yes, I have typed to him, so that's my
Oh,
problem right now. But
shame.
he cannot hear
Okay.
us. He can't hear
Oh,
anything.
shame. Poor
Guys,
guy.
remember to
Okay.
mute my people. I'm muting you, Nazi, but I can't actually mute you completely. It doesn't allow me. Hey, Nazi, can you please mute yourself? Okay. If not, it's okay. I'll just mute everybody. Sorry, teacher Lee. I've muted you because I needed that noise to be gone.
That's fine.
Thank
Not a
you.
problem. Thank you.
Thanks.
Okay, so a couple of people have put answers into the chat. Don't worry about that. You just keep doing your own thing. It doesn't matter what other people are doing. Great. So the people that have offered answers for 9.1, you've offered X coordinates at the turning points, work out what the Y coordinates are, and then see if you can go about doing question 9.2. And I'm going to work slowly behind you. Okay, so hopefully everybody's got the same answers. Right, very important here, matrix. You must show the first derivative. You must show the first derivative equals 0. On the line where you have your factors, you must show that they equal 0. Okay. Ayanda, I got the same. I got a different. I didn't get 448 over 27, but I could have made a mistake. I don't know what anybody else got. Yeah, Selma, that's what I got. Yeah, Mamelo, me too. Okay, so when I subbed in f of, are you subbing into the derivative or are you subbing into the original equation? Because you've got to sub into the original equation. So I also got 500 over 27. And when I subbed in f of 3, I also ended up with 0. Okay, so if they ask us for coordinates, we must give coordinates. So that means that the one pair of coordinates is -1 over 3 and 500 over 27. and the other pair of coordinates will be 3 and 0. Okay, so again, you must show the first derivative, first blue tick. You must show the derivative equal to 0, next blue tick. You must show your factors equal to 0. Okay, and then here we go, and then there and there. Okay, because that was out of 6 marks in this particular question. Okay, and Nhlanhla, what are you subbing into? Are you subbing into the original equation? Or are you subbing into the derivative? Because if you sub into the original, or maybe you just press something funny on the calculator, Nhlanhla, it definitely is 500 over 27. Yes, the original. Okay, maybe you just press something funny on the calculator. Just check that every x is minus 1 over 3 and that all your coefficients are correct. Okay, so we've got the coordinates at the turning point. Now we want to go ahead. And Nhlanhla, I hope you found your mistake. Now we want to go ahead and sketch the graph. Okay, it says indicating the intercepts with axes and the turning points. So that means, Matrix, that we need to know what the x-intercepts are. So I'm just going to move it up a little bit. Okay, can you calculate the x-intercepts, please, for 9.2? I'm going to let you guys do that as well. Calculate the x-intercepts, please. Have we got the x-intercepts yet? Still busy? Okay, that's fine. Not a problem. Let me know when you're done with the x-intercepts. You guys done with the x-intercepts? You still busy? Still busy. Okay, so everywhere says x equals 3, so there has to be more than one x-intercept in this case everywhere. But yes, x equals 3 is one of them. Okay, Lebogang, nice. Okay, so I don't know if you noticed up here, guys, they gave you f of x already factorized. So you didn't have to do synthetic division or inspection in this case. All right, so you should have discovered that x was equal to -2 or x was equal to 3. Okay, so because 3 is an x-intercept, here it is, it's an x-intercept, and it is a turning point. So we know that the y-coordinate is going to be 0 over here. So all we have to do is calculate what f of -2 is by subbing that back into the original. Okay, and Lebogang says she got 25. What did the rest of us get? Oh, sorry, it's an x-intercept. Of course you're going to get 0. Sorry, I'm talking nonsense here. Sorry, guys. Silly me. Leanne, why are you getting 25? Sorry, I'm being silly. It's an x-intercept. So of course you've got to get 0. Okay, sorry, it's not a turning point. We're working out an x-intercept. That's it. Correct, Guru. There we go, William. Yes, 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 yes. Perfect. Okay, so now we know the x-intercept. Do we know the y-intercept? Do we know the y-intercept? Do we know the coordinates of the y-intercept? Have a look at the equation matrix. Do you know the coordinates of the y-intercept? Yes, well done, William. 0 and 18. Perfect. Okay, good. Well done, everybody. Remember, it's our constant. That's our y-intercept. Okay, so now you need to sketch the graph. Again, what shape is the graph? Use the words concave down and concave up. Okay, what's the graph's shape? Good, Lebogang, good, Leanne. What's the shape of this particular graph? Look at the equation. That's it. Good. So first it is concave down, and then it is concave up. Okay, so we need to consider all of these things before we start sketching. Good. Well done, Mikhail. Mikweno. I hope I said that correctly and I didn't butcher your name. Gugu. Cool. All right. There was a hand that was up. Lebogang, go for it.
Now can you just say again why the y-intercept wasn't 25?
Oh, sorry, it's not 25 because we've been given it already. It's 18. Okay, so that constant that's given to you in your cubic is always going to be your y-intercept. I'm not sure where you got the 25 from. Okay, so it's this value over here that's always your y-intercept.
Oh, ma'am, I got the 25 because I substituted the -2 into the original formula.
Okay, all right. So something just went wrong there. Okay, never mind. Okay, so now we want to sketch our cubic function. So I'm just looking for space here. It's always so difficult to try and fit everything on the screen at the same time. All right, so we know that the graph, ooh, that's not very good. But anyway, there's our set of axes, never mind. Okay. So concave down and then concave up. Yes, absolutely. So we know that 3 is an x-intercept, and we know that -2 is an x-intercept. Where is the first turning point? The first turning point at -1/3 and 500/27 is in the second quadrant. So this graph has to be concave up. It has to have a turning point in the second quadrant, a positive y-intercept, and then it touches the x-axis at 3 and goes back up again. Okay, so this point over here was -2. This turning point over here was -1/3 and 500/27. This point over here was 3 and 0, and our y-intercept was 0 and 18. Okay, so that is what your graph should look like. Okay, concave down and then concave up. All right, so there were 4 marks here. There has to be a mark for your factors equal to 0, your x-intercepts, okay, and then I'm sure your graph would be marked with consistent accuracy marks. So I'm sure there would be a consistent accuracy on the turning points and a consistent accuracy on your x and y intercepts. Okay, is everybody happy with the sketching of the cubic function? Are we ready to move on and look at the next question? Yes, good. Well done, everybody. Lovely. Okay, cool beans. Now in 9.3, it asks us for which value or values of x will x times f prime x be smaller than 0 or negative. Okay, so let's try and dissect what this means. Okay, what does x times f prime x mean? What are we doing? What does that mean to you? Often we leave these questions out because we don't understand what the question is asking us. But once we understand what it means, it becomes much easier for us to access it. So what are they talking about when they say x times f prime x? What does that mean to you? Don't worry about getting it wrong. We all make mistakes. Have a go and share your ideas. Lebogang, go for it.
Ma'am, is it where the values of x are below the x-axis?
It could be.
It could.
It could be. But then again, it could also be the values. So the values of x is either to the left of the y-axis or to the right of the y-axis. So does it mean equal? No, unfortunately, it doesn't mean equal. Unfortunately, not an intersection, but I would understand why you would say that. Nhlanhla, you getting closer? William, you getting closer, but you don't have to do it algebraically. There we go. Iviwe, correct. Okay, so you guys are getting closer and closer. All right, so this means times. So x represents our inputs. F prime x represents our gradient, but we're actually talking about our signs. whether x is positive or whether x is negative, or whether gradient is positive or whether gradient is negative, because what they want from us is a negative outcome. So think back to grade 8. When you multiply two numbers together, how do you get a negative? How do you get a negative when you multiply two numbers together? There we go. So a positive times a negative is a negative. Good. So a positive times a negative gives us a negative. Exactly. Or a negative times a positive gives us a negative. So what they want us to do is they want us to consider where x is positive but gradient is negative. So the two need to be opposite sides. So where gradient is negative, so let's have a look at the first situation. Okay, so that's this one that I'm highlighting in pink, right? So let's first consider where x is negative, but gradient, sorry, where x is positive, but gradient is negative. So that means you need to look to the right of the y-axis, okay, where you are walking downhill. So between which two x numbers are you to the right of the y-axis, but you are walking downhill? That's it. Letabo, good. That's it, Nhlanhla, beautiful. Okay, so when you get to 0, when x is 0, when you get to 3, these x numbers here are positive, but you are walking downhill from 0 to 3. All right, so that's one of your answers. Okay, very good, Nhlanhla. So between 0 and 3, so we would write that as x is greater than 0, but smaller than 3. Good, that's part of your answer. Okay, so that is the only place where x is positive, your x in your inputs are positive and you're walking downhill. Now we have to consider the other situation. Let's highlight that in green. Now we want negative x values, but we're walking uphill. So where are x values negative? To the left of the y-axis. Where are we walking uphill? Someone had a very good answer. And Nhlanhla, it's not just from -2 to -1/3. I love your answers, Nhlanhla. As you even though it's smaller than -2, the gradient is still going to be negative. Can you see that, Nhlanhla? Okay, so that's going to be where x is a number that is smaller than -1/3. Okay, so in other words, this part of the graph over here. Okay, this is where your x's are negative, but you are walking uphill. Okay, the other part of the graph over there, your x's were positive, but you are walking downhill. Okay, so that would be the answer to 9.3. Okay, normally there are 2 accuracy marks and it has to be exactly like that on a compound inequality and 1 mark on that. Okay, the only other way you could write it would be with set builder notation where you're using brackets. Okay, so when x is a number that's smaller than -1/3, x is negative and gradient is positive. Or if x is a number that's bigger than 0 but smaller than 3, x is positive, but your gradient is negative. And Nhlanhla, go for it.
Good evening, ma'am.
Good evening. How are you?
I'm good, thanks. I was asking, for the answer, can it be x is greater than 0 or x is greater 3 is greater than or equal to x?
You can't split it up like that, no, because you're writing between. So when you write between in maths, it has to have a lower bound and an upper bound. So if you're
Okay.
writing, so what I'm doing here, I'm going to highlight it in pink for you. Okay, this over here, when you are writing between 0 and 3, but not including 0 and 3, you can only write it like that. The only other way that you're allowed to write it is like this. So x is an element of, and then you've got to use round brackets. You can do that.
Okay.
Okay, but that's the only other way you'd be able to write it.
Okay.
All right,
Okay,
so
ma'am.
well done. You did really nicely. Okay, and then over here, remember, x gets smaller to the left. So if x is smaller than -1/3, x is negative, but the gradient is positive. Because remember, that's a turning point. At the turning points, the gradient changes. Okay, so when x is a number that is smaller than -1/3, where your turning point is, your x is negative, as we had said, but your gradient is positive. Okay, so that explains the second part of the answer. Okay.